right, good morning, everyone, and welcome to our webinar, Molecules to Megawatts. I'm James Mowry, Operations Manager here at KAASM. As we get started, note that this 30-minute webinar is being recorded and will be available via the KAASM YouTube channel after the presentation. Also, you should all be muted, so if you have any questions or comments throughout the webinar, please click the question icon on your screen and type your question. We will address all questions and comments at the end. Now I will hand the microphone over to Sean Sandoval, President at KAASM, to begin the presentation.
Okay, thank you, James. Appreciate everybody for logging on to view this webinar and to learn a little bit about one of our WinCC Open Architecture users, UniEnergy Technologies. Over the next 30 minutes, we'll cover a few agenda topics. I'll share a little bit about KAASM, who we are and what we do. And then I'm also joined by the Director of Electrical Engineering, David Ridley, for UniEnergy Technologies. He's going to share a bit about their renewable energy technology and then also how they are putting WinCC Open Architecture to work as their software platform for their systems. And then at the end, we'll answer any questions that you may have and send out follow-up information on the video if you'd like to view it at a later date. So let's go ahead and get started. A little bit about KAASM. Our name, we are aptly named for bridging technology gaps. We are a value-added reseller for Siemens Industry Inc. and the PLM software business units for Siemens. We provide enterprise-level sales, support, and training. We provide real-world experience for the digital solutions that we provide, and we also have a personalized support offering along with a complete regional partner network of engineers. We also offer training courses to help with our customers' sustainability and digital adoption for the solutions that we are providing. A few notable comments about us as well. We are recognized by the Department of Homeland Security as a computer emergency response team organization, and our experience has spanned multiple vertical markets, and we've worked with well over 300 customers over the years. We've architected a number of systems regarding information management that range from the hundreds to hundreds of thousands of data points. Our company also believes heavily in training and educational events, so we offer webinars, tech tours, and certified training. If you'd like more information about that, you can visit us at our website, kaasm.com. Over these next few slides, I want to share a little bit about the technology solutions that we do provide or highlight a few of them. And our main core product that we promote is WinCC Open Architecture by Siemens. This is an information management and SCADA system that does really well with data management and distributing information to the right users in the right context at the right time. We also have a list of cloud-based solutions. The one that I would like to highlight here is LiveByte. For anyone looking for performance type data, specifically overall equipment effectiveness, we have a software and hardware combination that can provide dashboard and OEE metrics, very easy to access via the cloud. We also are working with a practical augmented reality software package called IQ Agent. This is a really unique package, and we believe that it's going to revolutionize the maintenance cart as we know it and how work orders are completed. Just by simply scanning a point of interest or QR code that you can see on the right of the screen there, we can grab the right information of a machine and speed up work order processes for maintenance personnel working on the plant floor. Things like documentation of the particular piece of equipment, OEM information, and also being able to screen capture and video record and send that information to anybody via email is all built into this application. Pretty great. We also work with quality management software. So we represent the Somatic IT R&D suite by Siemens, but we can offer everything from at-line and inline testing, connecting laboratory information to the plant floor, also providing a list of reporting from charting and trending to chain of custody, and then also certificate of analysis for the QA/QC release documentation and CFR 21 information needed in a lot of different customer type environments. We also have network management software, where in a very user-friendly environment, we can map out all nodes and networks and topologies into a simple software package that you can be able to access all data, run reports, and get information on the uptime of your network, and also makes it easier to troubleshoot and find network outages and keep firmware updates and so on with your software. And last but not least, we offer a range of hardware solutions from industrial PCs, network components, security appliances, sensors and RFIDs to complete the total solution to our customers. So in closing, KAASM can offer a one-stop shop for total factory automation and digital type applications for our customers. And we appreciate all of our customers, and we do the best of our abilities and provide information on education to help our customers with that adoption into the digital age. At this point, I'd like to introduce David Ridley, the Director of Electrical Engineering at UniEnergy Technologies, to share a little bit about what they're doing with their technology and also to share a little bit how they're leveraging WinCC Open Architecture. So David, I'd like to say thank you for joining us today. And at this point, we can hand over the presentation to you, and you can go ahead and start sharing UniEnergy Technologies.
Well, thanks, Sean. Appreciate the introduction. As Sean said, my name is Dave Ridley. I'm the Director of Electrical Engineering at UniEnergy Technologies. And so UniEnergy Technologies is I want to do a quick intro to the company, and then, as Sean mentioned, dive into a little bit of how and why we use the WinCC OA product for our supervisory level of control. So UET, or UniEnergy Technologies, is an energy storage company. We specialize in large megawatt scale stationary energy storage. What you're looking at on the screen now is one of the first deployments that we've done with a partner customer called the Vista Utilities out in Eastern Washington. This system is a 1 megawatt, 4 megawatt hour energy storage system. So roughly a 4-hour duration. This was deployed about 3 years ago, and we've been getting good runtime and good performance out of the system since then. UET has been around for about 5 years. We got our start as sort of a spinoff from Pacific Northwest National Labs. The company was formed to commercialize a new battery technology called the Generation 3 Vanadium Redox flow battery. And I'll come back to that in a couple of slides. So UET's mission is to commercialize this technology and to deploy large-scale energy storage for our for customers. So so why energy storage? What's causing this move to require energy storage in the market? So energy typically gets created through centralized generation. This has been the way it's been for years and years. So energy gets created at large generators, coal generators, nuclear generators, and gets put onto the transmission network, goes to substations where it gets put onto the distribution network, goes to transformers, which then serve end customer loads like our houses and our commercial and industrial facilities. So that was a very one-directional process in the past, where utilities had control over the power generation and customers were simple loads. What's changing now is that distributed generation, such as solar power and wind power, are becoming more and more cost-effective and therefore more and more popular in deployment in the end user distribution network. So what that creates is a grid that's moving from a centralized generation model to a distributed generation model. And there are significant challenges with that. Particularly, solar and wind power have a variable generation, and the utilities are struggling to manage that variability. That's one of the key drivers for energy storage. The next driver for energy storage is that simply the cost of traditional energy from the grid, the cost of coal and nuclear and such, is continually increasing, represented by the gray line here. And what's also happening simultaneously is that the cost of renewables are decreasing over time. So, you know, if we look at electricity prices over time, this trend is going to mean that at some point, if it hasn't already, the cost of renewable generation is going to, or has already started to, be more economical than the cost of traditional generation from the grid. So this really inflection point is really what's going to create the tipping point in the market, which I believe that we're seeing today. In the adoption of solar power, the adoption of wind power, and those are creating drivers and the need for energy storage at a large scale to deal with the variability of those generation sources. So who are our customers? We really target three key areas. Utilities and the grid use energy storage to manage the variability of loads. Commercial and industrial customers use energy storage to optimize their energy use. So utilities set a tariff. Commercial and industrial customers are beholden to that tariff, but can use tools like energy storage to optimize when and how they consume energy, including integrating renewable resources. The third market that we look at is the microgrid market. And these are off-grid scenarios or small grid scenarios that are traditionally run on diesel, but are finding that it's much more cost-effective nowadays to implement more renewables. But along with that comes the instability of renewables, therefore add storage to make your microgrid more stable. So how is UET going after this market? As I mentioned before, we've developed a large-scale, what's called Vanadium Redox flow battery with new technology coming from the Pacific National Lab, Northwest National Labs. And flow batteries are a different type of battery. The first thing to point out is that flow batteries separate the concepts of power and energy. So the amount of energy in a flow battery is how big the tanks of liquid electrolyte are. The amount of power in a flow battery is how many electrode cells and stacks are included with that set of electrolyte. But separating the concepts of power and energy allows us to be flexible in how we design energy storage. Flow batteries have a very long life in comparison to other types of batteries, typically 20 years or more. Also, flow batteries are very safe. They're intrinsically safe, in fact, with no flammable components used to build the system. And you get access to the complete range of the battery energy. So most batteries struggle to work at the extremes, whether that's at 100% state of charge or 0% state of charge. It can typically cause issues for the longevity of batteries. In our technology, that goes away. And then some of the other benefits that I've listed out here are, these batteries are very fast responding, can respond in milliseconds, but also back up that millisecond response with multiple hours of energy. It's a very low-cost technology. What's really interesting about the cost is that as we deploy longer and longer duration systems, so going to 4-hour, 6-hour, 8-hour systems, the dollars per kilowatt hour of the battery system actually gets lower and lower, because all we're doing in this case is we're adding more and more liquid electrolyte. So the scalability is pretty impressive. And a few other advantages, but I'm gonna move on here. So how do we architect the control system for our battery product? We've really adopted a 2-level control architecture, which we call the horse and rider topology. It's very familiar to everyone. We have a real-time layer of control that we call the BMS, the battery management system, manages the real-time functions of each battery module and creates a safe working environment for energy storage. The second layer of control, pictured on the top right here, is what we call our site controller, or our supervisory level of control. And that's where we've implemented WinCC OA for those supervisory functions. I'll come back to that. The architecture really is designed to be scalable to accommodate X, right? So how many batteries do you want? We deploy X number of batteries, and the control system accommodates whether we have 1 or 100. The control system creates a single point customer interface. We're trying to create a turnkey experience for our customers. Redundancy in any control architecture is important. We use a complete suite of off-the-shelf components from Siemens, one of the real benefits of working with Siemens. And this creates very flexible interface options as well. So I want to focus in on the site controller because that's where that's where we've selected WinCC OA as our platform, and I want to talk a little bit about that. So the site controller in our system, as I mentioned, is our supervisory level of control, and really has 4 key functions in the energy storage system. The first function is to aggregate data into a single control functions and data into a single location for the system, right? Create that single point interface for the customer. Take X batteries and make it act like 1 battery. The second thing is that it provides interfaces to both equipment and customers. So different customers want to talk with different protocols. The library of interface drivers is very important to us. Also, equipment that we utilize both in the battery control and in the power conversion control use different types of protocols. So having flexibility in the interface driver there is also very important. The third thing is that we manage the battery system with both monitoring and control. What this typically means is that we're matching the state of charge of all batteries in the system to make sure that all batteries charge and discharge together to maximize the amount of energy output of the complete battery system. The last function is that we use the site controller as a platform to implement the actual use case functions that our customers are trying to achieve. So whether that's peak shaving or voltage regulation or frequency regulation or backup power or whatever the application is that the customer wants to use energy storage for, this functionality gets implemented in the site controller. So why do we go down the road with WinCC OA? Why is this such a good fit for what we're trying to do? The first and most important point about WinCC OA is that it's object-oriented from the start to the finish. They've really taken that to heart, and I'm going to come back to that with a few examples of why object-oriented design is so important to our battery energy storage system. I'll come back to that in a few slides. The next feature of WinCC OA that is really important for us is the event-driven architecture. And this is the one reason that I threw up this graphic on the right. So if you look, this graphic probably doesn't make a lot of sense, but the key thing that I want to point out here is the one circle that's in the middle of the diagram, which is called the event manager. In terms of scalability for a control system, being able to only do the work that's necessary, which means only looking at things when they change, is super important for the scalability to be able to go from 1 megawatt to 100 megawatts of batteries. So the fact that the architecture of WinCC OA is 100% driven by this event manager, every single device, every single component in the system talks through the event manager, creates a very scalable system for us. The third feature that was really key for us, as I mentioned, we have a variety of interfaces to work with, and in fact, we worked with quite a few third-party products. WinCC Open Architecture enables third-party integrations. That's what open architecture means, and I have an example of that on the next slide. Also, lastly, the WinCC OA suite of tools comes with many pre-built functions that help you get started quickly. So whether that's built-in interfaces, built-in graphical tools, built-in database managers, when you think of something, there's a scheduler, drivers for various interfaces. If you can think of it, it's probably been done in one way or another already, and is part of the library that exists. So with those things, I'm going to move on to next slide here. Why is WinCC? So again, I mentioned open architecture. One of the reasons that this was important to us is that we use a third-party data historian for acquiring the data from our batteries and using that as a reporting tool for our field service team, and in fact to generate reports for our customers. So this is an example of how WinCC OA integrates with OSI Soft Pi Data Historian, and allows us to capture that data and present to our customers who a lot of times use OSI Pi themselves in a format that's very familiar and useful to them. The next slide here is about the control interface. So while we use OSI Pi for our data acquisition, WinCC OA is our control platform, and this is what we use for our control interface. The graphical editor and the built-in tools and widgets help us get going quickly with an HMI design, and you can see an example of something that we've put together for our battery dashboard here. Nice web-based design. So I want to come back to object-oriented because I felt that this was really, when it came down to it, this was the real key reason why we decided to go with WinCC OA as the tool of choice. And when you think about object-oriented, I kind of wanted to take the principles of object-oriented design and show examples of why it's so important to us and how it makes our job easier as we're developing this system. We're a very small team, and we need to make everyone needs to make the most efficient use of their resources, and object-oriented design helps you do that. One of the components that we integrate with as a battery system is a power converter. Batteries are DC, and the grid is AC. So we work with vendors, a number of vendors that you see here, to integrate power conversion electronics to convert that DC power to AC power for the grid. Different vendors have different strengths. Different markets have different vendors that are approved, and therefore we need to work with multiple vendors to accommodate the various markets that we're targeting. The principle of encapsulation allows us to easily accommodate vendor-specific features when it comes to these power converters. Every manufacturer implements things differently, and being able to encapsulate that as as a class of a device makes that process much more testable and much easier for us when we need to integrate a new manufacturer of a power converter. The next concept I want to talk about for object-oriented design is the concept of abstraction. We're at UET, we love talking about vanadium. We think it's the best thing that has ever happened to the energy storage world. But when you get to the point of somebody who's integrating a battery system, they don't really care about, how do you pump the vanadium and how does it work and how does it, all they really care about is make it work like a battery. So when the point of our BMS is to abstract away the fact that all of our technology-specific design requirements and turn it into a normal battery. And that's what we do. But even more interestingly, when it comes to a customer and the customer use case application, all they really want to do is put kilowatt hours in a box. So the site controller is really designed to abstract away all of that technology-specific engineering that goes into the product and turn it into a box that we can put kilowatt hours in. And that's what good abstraction allows you to do. That's why on our GUI you don't see icons of pumps and icons of ion selective, membrane separators. No, it's a tool that you can use to store kilowatt hours. So abstraction is a super important concept. The next concept is inheritance. And as a company, we offer 3 variants of our standard product. What you see is a 4-hour version of our product on the left, which is a 20-foot shipping container, a 6-hour version of our product in the middle, which is a 30-foot container, and a 40-foot version of the product, which is an 8-hour version. And the point here is that these batteries are treated exactly the same in the site controller. They inherit the parameters and the behavior of the base class battery, and that for us is important because we need, as a flow battery, as someone whose specific advantage is that we separate the concepts of power and energy. That's what makes the power of inheritance super important for us. The last principle of object-oriented design is actually polymorphism, but I don't have a good example of that. So I wanted to highlight why instantiation is so important for us. This picture is an example of a 2 megawatt, 8 megawatt hour system that we did for a local utility customer here in Everett, Washington. And as you can see, there's a lot of batteries here. Actually 16 of them to be precise. And the WinCC OA platform allowed us to simply instantiate 16 batteries, and we didn't have to develop those data models 16 times. We didn't have to write that code 16 times. It was instantiating those objects that already exist. So the power of instantiation is super important for us. So with that, just want to thank everyone for tuning in today. Appreciate your time, and here's my contact info. Thanks for allowing me to present and go with the flow. With that, I'll hand it back to Sean.
All right, thanks, Dave. At this time, we'll answer some of the questions we've received. So looks like they're all geared towards you, Dave. So first one, how does this technology compare to lithium batteries?
It's a good question. I think there's a few key differences to point out. The first one is safety. There are no flammable components in our battery, so it's a real advantage when to be able to install in environments where fire is a significant concern. I think the second big difference between lithium and vanadium flow is what we call cyclability. And we're all familiar with how batteries degrade and lose their energy and power over time the more that you use them, and that's called cycle-based degradation. With the vanadium flow battery, there's no physical mechanism for cycle-based degradation. We've done tens of thousands of cycles on our batteries with no performance loss at all. So it's a second significant advantage. Yeah, I could go on and on, but anyone who has more specific questions about that, we can dive in deeper.
All right. Yeah, thanks for that comprehensive answer. Next question. What's the most common feature you use in WinCC OA and why?
Yeah, so the most common feature, well, I mean, I think the core of what we use in WinCC OA, like I said, is the event manager and the data manager, right? So we're really using OA as the hub for all this data. So using that event manager and data manager, and then using the interfaces that OA provides to gain access to that. So, you know, we do, like I mentioned, we do use a suite of Siemens components, and WinCC OA has done a great job of helping us to integrate all of those components into one place.
Okay, thank you. And then in the interest of time, we'll ask one more question. So this one says, I saw the Everett install. How many other installations do you have?
Cool. Yeah, so let's see. We've done 5 installations to date, all megawatt scale. And I believe we've got around 10 or so more that are underway and will be deployed by next year. So it's definitely accelerating at this point.
Okay, great. Thanks, Dave. And the rest of you guys, if we did not address your question, we may be sending you a follow-up email with an answer to your question shortly. And with that, thank you, Sean and Dave, and a big thank you to our attendees. As I stated at the beginning, this webinar will be available for viewing via the KAASM YouTube channel. And thank you again for your attendance. We look forward to seeing you at the next KAASM webinar. Stay tuned.